Rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by M.L. Khanna sir, and I am Subuh Nadeem presenting you the videos of the concerned chapter. And the chapter which we are going to see here today is the chapter number 31 of volume 2, which is integration. So let us see some of the basic theoretical concepts involving it. So it involves a lot of concepts like indefinite integration. So what is indefinite integration? It is important to know. So I hope you have gone through the basic concepts. So indefinite integration means it is a reverse process of differentiation. So whenever you integrate a function fx and you say that it is capital Fx plus a constant of integration, it simply means that the derivative of capital Fx is a small fx. This is what indefinite integration means. There are few rules associated with sum rule and difference rule, and then we have product rule, and then we have quotient rule. So all these rules you have to remember, and after remembering these rules you should know some basic formula also. What are some basic formula? Like you have the derivative of sine x as cos x. So integration of cos x is sine x. Similarly, derivative of cos x is minus sine x. So the integration of sine x is minus cos x. So all those things, the formulas you have to remember. There are set of formulas. Some of the very important formulas of indefinite integration which you have to remember is there is a list. So we can't go through all of them right now, but I can give you an idea that we have formula of root over 1 by root over x square minus a square dx. Then we have integral of 1 by root over x square plus a square dx. Similarly, the list goes on. Similarly, we have the formula like integral of root over a square plus x square dx and integral of root over x square minus a square dx. And this list also goes on. So all these integral formula you have to remember. What else you have to remember is the partial fraction. So partial fraction, there are many cases of partial fraction when there is a fraction which is improper, when there is a fraction which is proper. So first we see if there is an improper fraction, then what we do, we change into proper fraction and then we apply partial fraction there. So these all concepts you have to take care of. Now you have to also take care of substitution method. You have to use trigonometric identities in indefinite integration. So these are all important things which you have to do. Next comes definite integration. So when we talk about definite integration, so in definite integration, there are limits. If we talk about limits, we generally take in formula a and b. So if we take the integration from a to b, fx dx, it will be equal to fb minus fa, like this. That is, we are putting on fx the limits a and b. So it will be fb minus fa. Now we have in this definite integration few properties associated with it. What are those properties? Those properties are such that if we have a to b fx dx, then we can change the variable and we can say that it is a to b fy dy. We have other property which says a to b fx dx is equal to minus b to a fx dx. We have another property which says that a to b fx dx is equal to a to c fx dx plus c to b fx dx, like this. So we can split it. Then we have many other properties. The list goes on. I'm writing one more property. A to b fx dx is equal to a to b f of a plus b minus x dx. So all these properties are there and we have to remember those properties. There will be the utilization of the properties in the questions which we are going to solve in this also and in the book also, and from the source which you are using, mostly the book, which is quite good. So the next is limit of sum. So when we talk about integration as limit of sum, so in that case what we say, that there is limit n tending towards infinity 1 by n f of r by n r equal to 1 to n can be written as. So one important thing is to be taken in care here while writing the formula, that the 1 by n part here becomes dx actually, f of r by n becomes f of x, and this summation becomes integral 0 to 1. So integration as limit of sum. For example, you have any equation 1 by n plus 2 by n plus 3 by n, so on till infinity, till n. So r equal to 1 to n. So n by n last. So this can be written as r equal to 1 by n. So I am writing this, each of these terms. So what I am doing, I am writing sigma and using r by n. So sigma r equal to 1 by n, r by n. Now this is multiplied by 1 by n, that is this is multiplied by 1 by n. So both are same. Now you have to find this summation. How do you find this summation? So one thing is that you take here, obviously there is a limit also, limit n tending towards infinity, and here also limit n tending towards infinity. So when you do the normal summation, what you do, limit n tending towards infinity, the LCM is n, so it is 1 by n square, and up in the numerator it is sum of the first n natural numbers, that is the formula n into n plus 1 by 2. Now you can write it as n square get cancels plus 1 by 2n. So when put the limit, you will get 1 by 2, right? After putting the limit, as 1 by n will become 0. Now you can use this result which we have discussed just now, and you can say that this is 0 to 1 f of x dx. Now what is f of x? It is r by n. So it is 1 by, it is simply x, right? It is simply x here. F of x is x dx. So this is f of r by n, which is r by n. So it is 0 to 1. Now you integrate it, you get x square by 2. Limit is 0 to 1. So you get 1 by 2. Now the last thing which we have to study here is also application of integral. The application of integral part says that if we have, suppose a curve which is like this, y is equal to f of x, then the area which it makes with the x-axis between x is equal to a to x is equal to b is y dx from a to b. This is the algebraic area. Similarly, if the curve is something like this and it is asked that y equal to c to y is equal to d, the area this is making with the y-axis, this is x is equal to gy. So it will be x dy from c to d. So this is the area. And then we have next with us is if there is an area between two curves like this from A to B, so we say this is f of x, this is g of x, and the area between them is f of x minus g of x dx from A to B. So this is the area between the two curves from A to B, algebraic area. So this is how we are going to implement. There is also similar case between y also. If there is a curve on the right minus curve on the left, then also gy minus fy from C to D can be taken. Now let us see few application part of all what we have studied and all the theory which you have done till now in this chapter. So this is the first question. This first question says that find the integration from 0 to pi by 2. So 0 to pi by 2 sin x plus cos x whole square by root over 1 plus sin 2x dx. So what you can say that it is 0 to pi by 2, and this will become sin square x plus cos square x, which will be 1, plus sin 2 sin x into cos x will be sin 2x, right? So it is 1 plus sin 2x, and in the denominator it is root over 1 plus sin 2x. So one thing will happen that you can write it at 0 to pi by 2 root over 1 plus sin 2x like this, because square root and power 1 will cancel like this. Then it will be 0 to pi by 2. Now again same 1 plus sin 2x can be written as sin x plus cos x ka whole square, because it will give on expansion 1 plus sin 2x. Sin square x plus cos square x 1 plus 2 sin x cos x, which is sin 2x. So you can write this as mod of sin x plus cos x, as a square and root will cancel and you will get a mod. One thing which is important here is basically if you have the mod, then you have to see the sign of this. So what is the limit? 0 to pi by 2. So x is in first quadrant. In first quadrant, we know that sin x is also positive and cos x is also positive. So this term is positive. So we can simply remove the mod sign and you say 0 to pi by 2 sin x plus cos x dx. Now when we integrate, integration of sin x will be minus cos x and integration of cos x will be sin x from 0 to pi by 2. Now when you put the limit, you get cos pi by 2 as 0 and cos 0 as 1. So you will get 1 here, as you will get 0 minus minus 1, right? And then we have sin pi by 2 which is 1 and sin 0 which is 0. So you get an answer 2. So you can say that option C is the correct option. Now let us come to the next question. The next question says here that sec x into cosec x. This is sec x into cosec x by log tan x, and you have to integrate this. So when you will integrate it, what you will do, that on integration of this, first of all, let us write it like this. This is 1 by cos x into sin x, and this is log of tan x dx. Now this is equal to, now cos x can be divided and can be multiplied like this. So 1 by cos square x is sec square x. And here we have sin x by cos x as tan x. So tan x into log of tan x dx. So you have to do a bit of manipulation also here. Now after doing this manipulation, you can do substitution. What substitution you can do? Let u is equal to log of tan x. Now when you differentiate u, you get 1 by tan x, and derivative of tan x is sec square x dx. So we have this one as integral sec square x dx as by tan x as u. So this term and this term with dx will combine with each other and you'll get du upon u. So this will become log of u plus c. We are taking log of u instead of mod u. That is fine. So this is log of tan x plus c. Ideally we can take mod also. Let us come to the next question. So the next question is about integration of this particular term. Now when you integrate this, you have to do a proper substitution. What substitution comes to your mind first? So if we say that, suppose 2 sine inverse x being taken as t, that is sine t by 2 is equal to x. So what will happen? This will become 1 by 1 minus x square, that is sine square t by 2, In the numerator, since it is integration with respect to x, so dx will be equal to 1 by 2 cos t by 2 dt. So this will be 1 by 2 into cos t by 2 dt. And then what happens to this? This will become t. So t square minus 9 under root. This is what it will become. Now this will become cos square t by 2. So 1 cos t by 2 will get cancelled. And you will get, as there is a square root here also, so this is also in a square root, right? This is also in a square root. So this will become cos t by 2. So cos t by 2 will cancel and you will get 1 by 2 dt upon root over t square minus 9. So 1 by 2 will come outside and cos t by 2 will cancel. This will be root over t square minus 9. Now there is a formula of 1 by root over x square minus a square, which is 1 by 2 log of mod of t plus root over t square minus 9 plus c. So this is 1 by 2 log of mod of t. Now t is actually 2 sine inverse x. So it is 2 sine inverse x plus root over 2 sine inverse x whole square minus 9 plus c. So this is how we can write it. Now let us come to the next question. So these formula you have to remember: 1 by a root over x square minus a square, 1 by root over x square plus a square, 1 by root over a square minus x square. All this formula you have to remember, of course. You can derive also, but it is better to remember. Next is integral of root over x log x whole square. So here what we will do, if we want to integrate it, we will take log of x as t. So x is equal to e to the power t. So dx is equal to e to the power t dt. Now this will become integral of root over x. So it will become e to the power t by 2. Log x whole square will be t square and dx will be e to the power t dt. So you will get t square e to the power t by 3t by 2 dt, like this. This is what you are getting. Now you apply the product rule. Product rule, that means here integration by parts. So isolate rule has to be followed in order to take u and v. So there is algebraic and there is exponential. Algebraic is first, exponential is last. So this is u, this is v. First function into integral of second, like this, minus integral derivative of first into integral of second is equal to 2 by 3 t square e to the power 3t by 2 minus 4 by 3, and again you have to apply the product rule. This is u here now and this is v here now. So you will apply the product rule again, and when you will apply the product rule, what will happen? It will become first function into integral of second function minus integral of derivative of first function, which will be 1, and e to the power 3 by 2 by 3 by 2 dt. So this is how you will write it. Now if you see the final answer, it would come out to be 2 by 3 t square e to the power 3t by 2. Next term would be minus 8 by 9, and it will be t e to the power 3t by 2, right? And next term will be plus, it is again becoming 8 by 9, and when you will integrate e to the power 3 by 2, then it will become 16 by 27 e to the power 3 by t by 2 plus c. So this is how you can express this answer. Now it is not in terms of t, so in the end you will replace t as log x. So replace t as log x everywhere and write the final answer. Let us come to the next question. So the next question here is integral of x square plus 1 by x square plus 2 to x square plus 1 dx. So when you integrate it, what will happen? It will be difficult to integrate as it is. So first take it outside and write x square plus 1 by x square plus 2. I'm not integrating it, I'm taking it outside and I'm replacing x square by u. I'm not replacing x square by u inside the integration. So no need to differentiate u. I hope you are understanding. You don't have to differentiate the x square term because we are not substituting inside the integration. I'm taking it outside, then I am substituting x square as u. Now apply the partial fraction. A by u plus 2 plus b by 2u plus 1. Now when you take the LCM, you will get u plus 1 is equal to 2a plus b into u plus a plus 2b. Now if you see here, what are the values which you are getting? So when you put u is equal to 0, a plus 2b is equal to 1, and similarly you get a plus 2b, 2a plus b is 1. So a plus 2b is also 1 and 2a plus b is also 1, which will give you the values of a and b. So what will be the values of a and b? If you subtract, you will get a minus b is equal to 0, that is a equal to b. So a is equal to b, which is equal to 1 by 3. So a and b both are equal and they are equal to 1 by 3. So you can write this one as 1 by 3 u plus 2 plus 1 by 3 2u plus 1, like this. Now after doing this, you can write this expression as this can be written like that. So this is 1 by 3, u is x square. So x square plus 1 dx plus 1 by 3 and 2u is 2x square plus 1 dx, like this. Now you can cross check also. If you take the LCM, you will get 3u plus 3 by 3, that is u plus 1 by the denominator. That is fine. Now you can write the answer here. This is 1 by 3 tan inverse of x by the formula, and this is 1 by 6 when you take 2 outside, and x square plus 1 by root 2 square, that will be 1 by a, that is root 2, tan inverse of x by root 2 plus c. So this will be the final answer. You can cross check. This is x square plus 1 by 2, as 1 by 2 can be written as 1 by root 2 whole square. So a is 1 by root 2. So this will be 1 by a. So a is 1 by root 2, right? So it is 1 by root 2 here. Not 1 by root 2, but 1 by root 2 here. And tan inverse of x by a, if you will write, then it is also x by 1 by root 2, like this. Because you are getting x square plus 1 by root 2 whole square after taking 2 as common. So a is equal to 1 by root 2. Okay. So this is all about formula here at the end. First you have to understand the concept, then you can apply the formula. Next is integration of x sine inverse x dx. This is Eilert rule again, the by parts rule. So Eilert gives you the algebraic function first, and in first is inverse trigonometry, then algebraic. So this is u, this is v. So first function into integral of second minus integral of derivative of first and integral of second, like this. So this will be x square sine inverse of x by 2 minus 1 by 2, and this is x square minus 1 plus 1 after simplification. So you can write it as plus here and take minus inside. So 1 minus x square minus 1 you can write. So this will become root over 1 minus x square dx, like this. So this would become x square by 2 sine inverse x plus 1 by 2, and this will become root over 1 minus x square integral, and then minus 1 by 2 integral of dx by root over 1 minus x square, like this. So after getting this, now you have to just apply the formula. I hope you remember all the formula. So we are applying the formula. What are the formula which we have to apply here? The first formula is a square minus x square under root, and the second formula is 1 by root over a square minus x square. So if we calculate, the first part is as it is, x square by 2 sine inverse of x, plus this is 1 by 2, and this is root over a square minus x square. So this will become x by 2 root over 1 minus x square, like this, plus a square by 2, that will be 1 by 2, into sine inverse of x by a, like this. This is what we are going to get here. What about here? This will give you minus 1 by 2 sine inverse of x. And as we know, a is 1 in both the cases. So no need to write a here. It is 1. So this is how you can express it. Right. Now let us come to the next question. So the next question says that we have limit of some question. Limit n tending towards infinity, root over n plus 1 plus root over n plus 2 till root over 2n. So how can this 2n be written as? This 2n can be written as n plus n. So the general form can be written as, and this root over n can be taken in each root. So general form can be written as 1 plus r by n, right? So this is 1 plus r by n and 1 by n outside. This n you can take outside, where limit n tending towards infinity. And sigma is from r is equal to 1 to n, as you will get 1 plus 1 by n as the first term and 1 plus n by n as the last term. So this will become equal to dx, and then r equal to 1 to 1 is 0 to 1, and this is root over 1 plus x. This integration is quite simple here. This is 1 plus x to the power 3 by 2 by 3 by 2, and the limit is 0 to 1. So this will give you 2 by 3, and you put the limit 1. So you will get 2 to the power 3 by 2, minus you put the limit 0, then you will get 1. So you get the answer as 2 into 2 root 2 minus 1 by 3. This will be the final answer which you will get. So this is a method in which we can use limit of sum and simplify different complex sequences. Next question is integral of 1 minus x mod from minus 1 to 1. So here, if you talk about mod of 1 minus x, so this mod of 1 minus x here is actually from minus 1 to 1. When x is from minus 1 to 1, then what can you say about 1 minus x? Can you tell that something about its sign? So 1 minus x will be greater than 0, because at 1 it will be equal to 0, and for all the values less than 1 it will be greater than 0. So minus 1 to 1, 1 minus x is greater than 0. As we know that here 1 is greater than x in this interval. So in such situation, this mod of 1 minus x can be simply written as 1 minus x. So this will be the integral minus 1 to 1, 1 minus x dx, which will become minus 1 to 1, the limits x from minus 1 to 1 minus x square by 2 minus 1 to 1. So this will become 1 minus minus 1, that is 2, minus 1 by 2, and this will become 0. So you get the value 2 over here. Prove that the area bounded by the parabola y is equal to x square and the line y is equal to 2x. So here it is written, the line is 4 by 3 square units. So here let us draw the diagram. Y is equal to x square is a parabola like this, and the line y is equal to 2x is a line like this, and the area included is this one. Now this is the intersection point 0. Another intersection point could be found out. X square is equal to 2x. So x will be 0 and 2. So this is 2. Now we know that the upper curve, which is the line 2x, minus lower curve, which is x square here, we can write it like this. And then we have the limit 0 to 2. So this area would be this one. Now this will give you x square minus x cube by 3 after integration from 0 to 2. So this will become 4 minus 8 by 3. So this will become 4 by 3 finally. So this is what we have to prove, that is, it is 4 by 3 square units, which we have proved. So that is all for today's class, students. Now we will meet in the next video lecture. Thank you.